Okay, I'm not gonna lie, this one took me a long time. Okay, I'll tell you specifically what part. Okay, so first of all, we have a length, a mass. I'm talking fast because I really do think it might take the full 10 minutes that I get for free. But you know what? It might be a two-parter. That's okay. We want to know the angular acceleration. We are rotating. So angular acceleration, I'm thinking either kinematics or torque equals I alpha. Since they gave us I feel like it's torque equals I alpha. This is the rotational version of F equals ma, torque equals I alpha. So I'm going to do torque over I will equal our alpha. So we have to figure out our torque, which is tricky for a few reasons. This is what took me so long. Okay, so torque is R times F. But that F has to be perpendicular to the axis of rotation. So if you have a door and you're pushing it, you are perpendicular to the axis of rotation. If you're bad at physics and you push it at a weird angle, only the part of that push that's at, only the component that's at a right angle counts. The rest of it, this bit that's going up, that's wasted. So you have to do sine cosine stuff. All right. So I practiced so I could show y'all. Let's do this. So if we have RL, first of all, what is the force that's causing us to rotate? Well, it's the force of gravity. It's the fact that this thing has mass. It's going to pull it over. The mass we calculate as being halfway through. Ooh, we can't see that. So if this was just a rod that was like horizontal, and they were like, the mass is 1.94, we'd be like, cool, I'm going to pretend it's in the middle and say that that's mg, and that's where it is. It is, if the pivot was right here, we'd be like, it's that far from the pivot. Even though, like, obviously the whole rod has mass, but we're pretending that it's just in the middle. That's what we do in AP Physics 1. You're allowed to do that. All right, so we're going to pretend our mass is all in the middle. FG is going straight down. Part of it is causing a rotation because part of that, a wee little component of that is at a 90-degree angle to our axis of rotation. Not a lot. Let me draw it real exaggerated. So this is our L. This is our theta. If this is our FG going down, part of it, a very small part of it, is at a right angle to our axis of rotation. Just a little bit. Most of it's going down, but part of it is technically at a right angle. So the rest of it is going along. So the FG is the hypotenuse of our weird triangle. Here's my triangle. FG, we are only really caring about the bit that's at a right angle to our axis of rotation. Here's our triangle. This is the part we care about. They gave us this angle. They said that's theta. So the bit that's causing the rotation is FG sine theta. It's opposite that angle. We're not going to talk about how long that took me to figure out, but I got there. Okay, so we're going to do torque over I. So torque over I is going to equal our alpha. So the torque is RF in the direction of motion. The F is FG sine theta. The I is 1/3 ml squared. So let's think about this. Equals alpha. The R for our torque, where is that torque being applied? It's being applied exactly halfway through. So that's L over 2 instead of R. Our FG is just mg times the sine of theta over 1/3 ml squared. Our m's cancel out. One of these L's cancels this L. So we end up with 1/2 g sine 19.7 over 1/3 0.871. And if you plug that into your calculator, you do get this 5.7 number. Figuring out that triangle, though, for me, this was the hard bit. That's a gnarly triangle, especially with such a shallow angle. I really did draw it bigger just to like logic through. But what I did is I drew stuff I knew, like if this was, I don't know, a rod being held up by a tension string, I knew like, okay, I would do FG down here and this would be like tension. And if they gave me this angle, I'd be like, well, that's T sine theta. So then I mentally like rotated this whole thing to try to put it in this like new context that I didn't understand yet. So that's how I kind of like taught myself how to make that triangle. So that's how you do that gnarly one.